Let's take a look at different types of memory that are used in computers and electronic devices. In my introduction to computer system architecture, I didn't actually define what RAM memory is. Therefore, this is a good opportunity to take a look at the different types of memory that are sometimes in use on different computer systems. We'll first take a look at read-only memory. Read-only. This is a type of memory that's typically pre-configured during manufacturing. It might be used as a small bit of memory in, say, a digital clock, a type of memory that is not going to change very frequently. We're not going to be doing software updates to it later on. So I'll just do it during manufacture, put the data that needs to be stored into read-only memory. There's another type known as programmable read-only memory. Sloppy handwriting there. Programmable read-only memory is basically a read-only memory device that's blank, but we can program it one time. So we can write to it one time, set it up, store data into it. Once we've done that, we're done. We can't go back and erase it. There's another type, though, that is called erasable. Erasable, programmable, read-only memory. This is a type of programmable memory that we can go back and erase and then fill in the values again. Typically, however, it's going to be limited to erasing all of the memory at once and rewriting all of the memory at once. It's not going to be memory where we can go in and say change a single byte of data. We have to do all of it when we read or write from it. Finally, we have something called electrically erasable. Electrically erasable programmable read-only memory. What a mouthful. Basically, that is memory that we can go in, write it, and go back later, change it again, erase it, do whatever we need to some number of times. Now, how many times is that? It's typically limited to, say, 100K, some versions up to about 1 million times. We'll make that look like a 1 there. Oh, that looks more like a 2. But this is a type of memory that we can go through, program it, change it later on, and go back and forth, and address it a byte at a time. Flash memory is basically a form of EEPROM, and that means that we can change it over time. And flash is also limited to a maximum number of reads and writes that we can go into that, say 100,000 times up to around 1 million times or so. Now, at first that may sound, I'm going to overwrite my flash memory too many times, and we're going to wear it out and it won't be usable anymore. Realistically, each time you install software updates or whatnot to, say, your Android smartphone app, that counts as one time that you're rewriting the memory. One of the things it does, however, is it tries to, let's say we have our memory out like this, and we have stored some information in a section of memory, and now we'd like to go rewrite it. Well, what we do is, through some methods that are used here, we mark this as, okay, that's old data now, and now we're going to put our new data out here where it hasn't been used before. And so we try to go intelligently to spread our writing of data over the surface area of that memory, so that we aren't just always rewriting the same area over and over and over again. In this way, we actually do get very long lifetime out of that flash memory, because when you think about it, we're probably not going to update our software 100,000 times or 1 million times. I'm going to distinguish here now between the types of memory we've talked about up here and the type of memory we're going to talk about next, RAM memory. RAM memory stands for Random Access Memory. That means we can read or write an individual byte, or sometimes a collection of bytes, anywhere spread throughout that memory system. A major distinction between the memory that we looked up here and RAM memory down here is that here we can turn off the power and we do not lose the content of our data. Whereas here we need to have power applied all the time to retain a value in random access memory. If we turn off the power, the memory is essentially erased. It is obliterated. We no longer know what was stored there. So that's an important distinction here. And this is a type of memory that we may wish to use because we don't always wish to have it powered on. Now there is a version here of RAM memory that gets around this somewhat by having a battery backed up RAM. And what that means is power is maintained to the RAM from a battery. As long as the battery remains connected, we can turn off our system power and still retain the content of the RAM memory. Now there's also two versions of RAM, one called dynamic RAM, that's what the D stands for, the other is SRAM or static RAM. Static RAM uses more components than dynamic RAM, and dynamic RAM is smaller per bit. That means we can create larger memories in less space with dynamic RAM. So the main advantage here is it's cheaper, and we can pack the information more densely and make larger memories. So most of our RAM that we're going to be using on computer systems is going to be of that type, dynamic RAM memory. We also, of course, have the solid state drive, which is basically a form of flash memory as well. And then for the sake of history, we have a very old technology called magnetic core memory. Core memory was actually magnetized cores. They stored a little bit of magnetized information, so to speak, for each bit. And it was very expensive. Cost originally about $1 a bit, US dollar per bit to create, eventually getting down to about 1 penny per bit. And at that point, semiconductors like static RAM and so on became available and were able to be manufactured at lower cost. But this was what was used up to about the early 1970s in a number of computer systems. Relatively expensive and not actually all that fast compared to our modern memory systems. I mention this because the term core is a term that still gets used in computing. And if you've ever had an operating system crash, and it may have done something called dumping the contents of memory and CPU registers and so on, that is sometimes referred to as a core dump. So that term exists still today, and it refers to copying the content of memory after the system has crashed. And that way a programmer can go back and take a look at that snapshot of what the memory looked like at the time of crash and hopefully find a solution to what was causing the system to fail. So that, there you have it, is basically a very quick review of different types of memory. And I think the main thing for you to know is that dynamic RAM, random access memory, always requires power, and it's what we use primarily in all of our computer systems. These other types of memory up here have some special purpose applications. Certainly EEPROM flash we use in our smartphones a lot, and we do see that in other devices as well. But the key difference here is we can turn off the power and we don't lose the content of memory. Whereas with RAM, we turn off the power, we lose that memory. So there you have it.